Hey everyone, welcome. This is page 404, error 404. Let's go. Because you prove that the relationship is true, you can now refer to it as a theorem. And so you should make a note card or remember just this relationship from time to time. The parallelogram congruent parallel side theorem. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. Thank you, Ray. That was 100% something that everyone needed to know. Great guy. Let's talk about a rhombus, the next one in our specific list of quadrilateral shapes. And so something that we get from a rhombus is that it's also a parallelogram. All right, wait, how though? Okay, so one thing that we know is that a rhombus has four sides and all four of those sides are the same length. We can even create a rhombus using a compass and a straight edge. In order to prove that a rhombus is a parallelogram, we have to prove that its opposite sides are parallel. Let's use side, side, side. And let's focus on triangle HRO and triangle MOR. We'll focus on those two triangles specifically. So something we can say about those two triangles is that, well, their sides are all congruent. So like this side, HR, matches this side in the other triangle, OM. So those are the corresponding sides. But that doesn't deter us from using one spike on HO and one spike on MR because those sides that are corresponding are also sides of a rhombus, and so therefore they are congruent. Furthermore, if you draw a diagonal, and the diagonal that we're focusing on, well, it's the RO diagonal. It's actually the same in both triangles, just depending on the lens with which you're looking at it. So RO is congruent to OR. That's used in both triangles. It's like these letters and those letters in the actual like triangle congruence, RO, OR. It's the same. It's reflexive property. So therefore, we actually have coloration time. We have side, side, and side, which is what we're saying focus on for the proof. Now, not a formal proof in that it doesn't have the formal write-up, but it's enough logic there that it actually allows us to then say, you know what, the corresponding angles, like angle HRO, this angle is going to match MOR. Those angles are the same. And also, angle HOR is this angle, and it's the same as MRO. And so those two angles are the same. They're actually equal to each other, but that's a different thing we need to talk about. Since those angles are the same by corresponding parts of congruent triangles, the triangles are congruent, so the angles are congruent, but it creates the alternate interior angles converse theorem, and therefore we actually do have a parallelogram. So I'm going to add in the notation for the arrows to tell us we do. We have a parallelogram here. It's a rhombus, and a rhombus is a parallelogram. Since a rhombus is a parallelogram, which properties hold true for all rhombi, which multiple, right? So then we go back to our page 420 flowchart, and we look at what a parallelogram has for its conditions. A parallelogram has opposite sides are congruent, opposite angles are congruent, and the diagonals bisect each other. And you know what? All of those three things are also the same for a rhombus. Because in a rhombus, opposite sides are congruent, opposite sides are congruent. Opposite angles are parallel, opposite angles are parallel, and the diagonals bisect each other. And for that reason, we can write them down. Those properties of a parallelogram are also true for rhombuses. We have our own conditions we're going to prove for rhombi, like the diagonals are perpendicular, but we'll save that for the next video. Thank you for watching this one. Like, comment, and subscribe. See you on page 405. Bye.